Hey guys, so before we get into today's lesson and start talking about quadratic function, I want you to look at the stream, okay? I posted no Zoom today, but I would like you to go ahead and click on that attendance form so you can get credit for being here today. Okay, that's the first thing. And the second thing is a STAR prep / intervention that begins today and the rest of April all the way through STAR test. Okay, so if you click on that PDF, there's a calendar of topics, okay, per date, right? So if you look for today and tomorrow, because it's an A day, B day, right? During your A2 and B2, we're going to talk about domain and range of all functions. Okay, so domain and range of all functions. You can click to sign up for topics based off of the dates that you can attend. Okay, so if you click where it says here, this will pop up for you. Go ahead and fill it out. If you know that there's some topics that you struggle with and you want more practice on, you can go ahead and sign up for them now. Okay, make sure you click whether you're going to attend during A2 or B2. If you want to wait to fill this out, okay, then you can wait until you receive that document that I talked about in today's assignment, okay, in Google Classroom. Because I'm going to make a document for each of you that has benchmark scores and unit test data of topics that I feel we should practice on just because we're scoring lower on those. Okay, so you can wait to receive your data, or you can go ahead and start signing up for some based off of days that you are available, that you don't have practice or something else scheduled. Okay, so go ahead and take a look at that. I'm going to go ahead and start opening up today's assignment so we can go ahead and get ready for that. Okay, so today's assignment is over the quadratic function. Okay, there is something that these three equations have in common that make it quadratic. So if you remember, before we started doing benchmark and before we started reviewing old material that was going to be on the benchmark, we started a new type of equation or function, right? And we call that the quadratic. Okay, so these should not look brand new to you because we have talked about these. And remember, we looked for the zeros or the solutions, right? We found the y-intercept, the vertex, axis of symmetry. Okay, so that is hopefully starting to trigger some things relating to quadratic. Okay, so on this first slide, I just want you to tell me some things that are the same and then some things that are different between these three equations. Okay, if you need to press pause, go ahead and press pause so you can fill it out, and then we're going to move on to the next one. Okay, so on slide 2, I just want you to sketch me a picture of what you remember these to look like. So one of them I want to have a minimum, okay, and the other one I want to have a maximum, okay? Oops. One of them I want to have a minimum, again, minimum vertex, and the other I want to have a maximum vertex. So you don't have to be accurate, put it on a graph or anything like that. I just want a sketch. Sketch is just a picture of what you remember them to be. If we forgot, okay, you can go to Desmos and you can type this in. Y equals x squared. That'll give you an idea of what they start to look like. Okay, original, I'm going to often call it the parent function. That is how it starts before we start moving it around on the graph. Okay, so the standard form, right? Standard form just means that it looks a little bit different than the x squared. We start adding different components to it. Okay, so A, B, and C are just numbers, right? They're just variables in our equation. Okay, so a lot like the standard linear, right? We had AX plus BY equals C. Well, this time we've got A, B, and C all on the same side. This little 2 right here makes it quadratic. So that's what gives it the U shape or the N shape. Okay? If we look at the A value and it is positive, then my curve is going to have a minimum and it's going to be opening up. If it has a negative value, it's going to be facing down. So it opens down and it's going to have a maximum value. This number over here at the back, this plus C, is just my y-intercept. And we know what y-intercept is. We're good at that. Okay? Next way or next version of the same type is vertex form. Okay? The reason why we call it vertex form is because I can pull the vertex straight from my equation. Okay? I've got an H and a K. That's how I build my vertex, H, K. Remember, vertex is the lowest point or the highest point. Okay, remember how we did slope-intercept form? And we called it slope-intercept because you can find the slope and the intercept just by looking at the problem? Same works here. I can find the vertex just by looking at my equation. Okay, so I'm going to talk about the different parts in that equation. Okay, when we are building our vertex, capital but, right, we take the opposite of the H that's in parentheses. So if it was -3, my H value would really just be a 3, okay? And then whatever my K is, okay? That's a good place to start. So the A tells you positive or negative, okay? Whether it opens up or down. We're not going to pay too much attention to what the actual A value is yet, okay? We can talk more about that when we start seeing different types of pictures, whether my A is bigger than 1 or smaller than 1, okay? So now we're going to talk about this H right here in parentheses. So we take opposite of it and it becomes the X value of my vertex. But it also makes it shift left or right. If we see the minus sign, we usually think that's the left direction, right? Because that's what it is on the number line. If you see parentheses, you do opposite. So my curve is going to shift to the right. And then the same for plus. If you see plus, we're going to think opposite and it is going to move to the left. Then this number over here at the back, this plus K, it's either going to go up or down. If it's positive, it's going to move up. If it's negative, it's going to move down. Okay, so let's try one. So please ignore that big gray box right here in the middle. This is your next slide. So if you want to move to the next one, we're going to pull the vertex out first. So my vertex, remember, is HK. But it is opposite of whatever my H is right here. Okay, so my vertex will be 1, 4. Okay, if I look at my A value, this is my A, it is positive. That means that my curve is going to look like this, right? That means that my vertex will be here, and it is at 1, 4. Okay, and I've gotten all of this information just by looking at my equation. Okay, so now I'm going to look here. X minus 1. This means that it is moving, right? It is shifting. If it's minus, remember opposite. So this one is shifting right 1 time. And then my plus 4 over here at the back, that means that it's going up 4. And that's it. So my A was positive. It made my curve face up. In parentheses, I had a minus sign. Opposite of minus, right, is to the right, right? Because usually left is minus, but parentheses mean opposite. So it is shifting to the right one time because it was the number 1. And then my +4 right here, that's going to be normal, regular. It went up 4 times. Okay, so I want you to try the next few. Follow what I did. Okay. Okay, so I want you to start by taking out the vertex. If you don't have an H value, then it's 0. Okay. Then I want you to check for your A value, whether it opens up or down. Does it shift left or right? And then does it move up or down? Okay, on this one, since it is vertex form, my main focus is not going to be on the A value. What I want you to use the A value for is just to determine whether it opens up or down. Okay, you can plot points by plugging in, okay, to get exact points, but I'm not looking for exact today. What I'm looking for is you being able to identify the vertex. Okay, so this would be an example of my H, right? It's positive, so opposite would be a -2. So my vertex for this one would be at -2, -1. Okay, and I can't actually draw on here, so you're gonna have to plot it for yourself. If you look at your A, you can see that the A is positive, so your curve should be facing up. Your vertex should be at -2, -1. It should shift to the right 2 times. I'm sorry, left. See, that plus sign threw me off. Plus sign, we do opposite. So it should move to the left 2 times and then down 1. Okay, so on the one that tells you to write the equation, okay, remember my focus today is going to be on can we identify the vertex, okay, and how we think it shifted and where we think it moved, okay? So I don't necessarily want to focus on how to find that A right now, but I do want you to tell me if that A should be positive value or negative value, okay? And the same for the next one. Just tell me whether the A should be positive or negative. Find the vertex and try to plug them into that equation, okay? You have 2 questions to work on, but one of those slides, you have to explain how you got that answer, okay? You can either use the picture to help you, or you can use the actual equation that was given to you in the problem. Okay, I want to see what we come up with for that one. And then the last one, use the equation to help you, okay?